Hey, this is Mr. Janes, and in this video we're going to learn how to do two things. First, we're going to learn how to find slope on a graph, and second, we're going to learn how to find distance between 2 points on a graph. More specifically, we're going to look at IXL E2, which is slope, and IXL B8, which is the distance formula. So, we'll start with slope. In this problem, let's see, we're looking at this graph, we've got to find the slope between 2 points. Well, so let's start by picking any 2 points in the graph, although it's easiest to pick 2 points that go through the coordinate grid. So I'm going to pick this point right here and this point right here. That looks good. 2 points. Now slope. Slope, remember, is rise over run. Okay, rise over run. So we're going to figure out how far we've got to go to the right. Okay. And how far we've got to go up on our graph to get from one point to the next. So in this case, our rise is our run is 1, 2, 3, 4, 5. So our run is 5, but watch out, the graph goes in increments of 10, so that's actually 50. Our run is 50, so I put that up here. Our run is 50. And our rise, let's see, our rise, well, it just goes up 1 grid mark, but it's going up by tens, so our rise is 10. So 10 over 50. And if we simplify that, we get 1 over 5. And that is our slope. Okay, that's our slope. Now there's a couple other ways to do slope, right? It doesn't have to be rise over run. Some people remember it as change in y over change in x. So let's say we had points here. This point would be 0, 40. So 0, 40. It's our first point. 40. And our second point would be, let's see, 50, 50. 50. Good. And now, slope is change in y over change in x. Okay. And so let's look at our change in y first, right? I'm at 40, and I'm going up to 50, so that means I've got an increase of 10, right? So my change in y is adding 10, okay. And then my change in x, well, I was at 0, and now I'm at 50, so I've increased by 50. So my slope is 10 over 50, positive 10 over positive 50, which simplifies to 1/5. I get the same answer. All right, sounds good. Now there's one other way to find slope, okay, and that is to use the formula. Now the formula is really the last resort. You want to be using rise over run or change in y over change in x before you use the formula. Even if you're given 2 points, you can use change in y over change in x instead of the formula, right? It's easy to forget the formula, but it's much harder to forget rise over run. So let's do the formula just because. So the formula is y2 minus y1 over x2 minus x1. Okay. So now when we look at these points, I've got my my x1, y1, my x2, and my y2. Okay. So my y2, let's see, is 50. My y1 is 40. My x2 is 50. My x1 is 0. 50 minus 40 is 10. 50 minus 0 is 50. 10 divided by 50 reduces to 1/5, and that is your slope. Now I've done slope 3 different ways. I would do, as much as possible, I would try and do rise over run or change in y over change in x. You really don't need to be using the slope formula all the time. All we're doing to find slope is we're finding how much is x increasing, how much is y increasing from one number to the next. Right? And you can do that by subtracting, which is what the slope formula does, but you really don't need to do that. Let me give you an example where we don't have the graph in front of us. Okay, so we've got another problem here with no graph in front of us. We've got to find the slope between those 2 points. Now you could pull out the slope formula, right? y2 minus y1 over x2 minus x1. But do you really need to do that? Maybe. We're going to try not to use that. Because the chances are, if you're using this, you might come up with a wrong answer, just because maybe you put in a wrong number, you press buttons on your calculator the wrong way, something like that. So let's try not to use that. Instead, we're going to try and use change in y over change in x. Okay, so let's see how to use that. Well, change in y. Remember, the last two numbers, 7 and 8, that's my y coordinates. So from 7 to 8, what's happening? Well, I'm increasing, going up by 1. So that'll be plus 1. That's my change in y. And then for x, let's see, I've got 10 to 1. Looks like I'm decreasing or going down, subtracting, by 9. Okay, so I'm going down by 9. So plus 1 for y, going down by 9, negative 9 for x. So I've got 1 over negative 9, which can be written as negative 1/9 for a slope. All right, that's your slope right there, negative 1/9. Let me put that in to make sure we're all set. Okay. Okay. Negative 1/9. Okay, and we're good. Right. So now we're going to look at doing a distance formula problem. So this is IXL B8 distance formula. So before we're doing slope, and with slope you could pick any 2 points on the line. But for distance you can't. Distance you got to pick the 2 endpoints of the line you're working with. So in that case that's this point right here. That's this point right here. Why is that? Well, let's think. Slope has to do with steepness, how steep a line is, right? So it doesn't matter where you are on the line is still the same level of steepness. However, for distance, if you change where you are on the line, say we went from maybe here to here instead of the whole way, okay? This distance is much shorter than the whole distance right here, okay? It's the same level of steepness, so the slope would be the same, but the distance would not. So for distance formula, remember, always use the start and the end of your line. So how are we going to find distance? Well, we could use the distance formula. Remember, that's square root of y2 minus y1 squared plus x2 minus x1 squared, and the whole thing's under a giant square root. And again, just like before, we could use the distance formula, but it's actually easier and faster if we don't, right? I'll show you how. We're going to use the Pythagorean theorem, okay? For those of you who don't remember what the Pythagorean theorem is, it's a squared plus b squared equals c squared. That's all it is. And this works if you're given 2 of the sides of a right triangle and you need to find the third, okay? So we're given this triangle right here, okay? And we know actually what these 2 sides, this side, we'll call it A, this side we'll call it B, we'll call this side C. And the distance right here is the same as if we found C. So what's A and what's B? Well, A, for us, is just going to be our change in Y, okay? And B is going to be our change in X, okay? Change in Y, change in X. We're going to square those 2 numbers, add them together, okay? Square those numbers, add them together, and then take a square root at the end, just like we would for the Pythagorean theorem. So let's see. What's my change in Y right now? Well, my change in Y, I start at 0, go up to 16, so my change in Y is 16. My change in X, I go from 0 to 12, so my change in X is 12. So let's put that into the Pythagorean theorem. So my change in Y, 16 squared, plus my change in X was 12, 12 squared equals c squared. So let's see. Let's pause for a second and grab a calculator. Right, so 16 squared, there's no squared button, so that's 16 times 16, okay, is 256, okay, 256 plus 12 squared, I know this one in my head, but I'll do it out just in case, yeah, 144, okay, equals c squared, 256 plus 144 equals 400 equals c squared. Okay, and so I need to get c by itself, right? I'm searching for the distance here. So to get c by itself, I take the square root of both sides, okay? And the square root of 400, well, let's do it in the calculator. So 400 square root, okay, is 20. So c equals 20. Remember, c C here was the distance, get back on this page, C here was the distance between these 2 points. So that means my distance is 20 units. I type that in, double check that. Okay. 20 units. Looks good. So at this point you're probably saying, well, Mr. James, it's pretty easy if we have a graph in front of us, right? We can just see the right triangle, we can do it pretty easy. So I'm going to do this next one without using the graph, and it will still give me the same thing. So let me cross the graph off, not going to use that. I'm only going to use this information they give me here. So again, I'm going to use Pythagorean theorem instead of the distance formula, because to me it's just much easier, right? A squared plus b squared equals c squared. Not a lot of stuff to remember, pretty easy. Now a and b, well, that's our change in y and change in x. So let me just write that here. Remember, our change in y and our change in x. Okay, and then c will be our distance that we're trying to find. Distance. Okay, so just like slope, we're going to find our change in y and change in x, and then drop those into this formula. So let's see, I'll do this in blue. Change in y, well, I'll go from 15 to 0. Looks like I'm decreasing by 15. So my change in y will be negative 15 squared plus my change in x. So my change in x, I'm going from 0 to 8. 0 to 8, that's increasing by 8. So 8 squared equals c squared. Okay. Now 15 squared, that's negative 15 times negative 15. Remember, whenever you square a negative number, it becomes positive. So let me grab my calculator for a second. Okay, so we got 15 times 15. Okay, 225 there. Okay, 8 squared, I hope we don't need to use the calculator for this. It's 64. Okay, equals c squared. Let's add those two numbers together. 225 plus 64 equals 289. Okay, 289 equals c squared. Not done yet because I've got this squared here. Okay, and to undo the squared, to undo that square, I need to use a square root. So take the square root of both sides. Okay, square root of both sides. The square and the square root cancel each other out. And let's see, the square root of 289. Let's go to our calculator. Square root. Oh, it's 17. That's nice. 17 equals c. Okay, so since c was our distance, 17 is going to be our answer. So we'll double check that by going back to the problem. Okay. Okay. 17. Looks good. And so the important thing to remember here is as we're doing these, right, for both slope and distance formula, you're finding the change in y and change in x. The only difference is this. And I'll write these right here so you can keep them up or memorize them as you're doing your homework. Right? For slope, okay, need some ink here. For slope, you're doing change in y divided by change in x. There's the division going on with the slope. But for distance, okay, you're taking that change and putting it in to Pythagorean theorem. Change in y squared plus change in x squared equals your distance squared, which is c squared, right? So you square both of those numbers, you add them up, you take the square root to get c by itself, and you're done, right? So slope and distance formula are actually pretty similar because they both use change in y over change in x, but they use those two numbers a little differently. Good luck, and I'll see you in class tomorrow.